So imagine this situation. You have installed a FreeBSD system and configured it and installed some packages. Now you'd like to deploy a second system and use the cache, the installed applications you had before, but the second system doesn't have access to the internet. Can you use the cache as a repository for the second virtual machine? Okay, let's have a look. So what happens is that when you install package on a FreeBSD system, the packages get saved in a local cache directory. The current state of your system is also reflected by a local SQLite database. When you do a PKG install, the packages get pulled from the repository which is configured in your system. If you want to install the same software you just installed, like for example in 100 machines, and you are using the same repository, this means that you would be pulling 100 times the same packages from the same repository. This has high bandwidth costs and also time. So wouldn't it be nice that we can transform a local cache into a package repository in the form of a mirror? To address this, I have developed a small Python script that converts a local PKG cache into a PKG mirror or repository. It also creates an ISO image that can be easily mounted, or it can be easily burned into a DVD or a CD. This mirror repository can then be configured in your target machine and can be used to install the software you have previously installed and that was already present in the cache. Please note that the small Python script that I've developed should not be used in productive systems. In this video I will be using two FreeBSD virtual machines which are running under VMware on a Mac OS. I'm going to use the first machine to create my mirror, and the second machine is basically an empty machine where I can test my mirror. In this video I want to show how to create this mirror and how to bootstrap the PKG on a target machine, which is just a bare bones installation, and I'm going also to show how to install packages and configure the system in the target machine. Before this video I have prepared a few things. The first machine, which is going to be used to create a mirror, has already been pre-configured and I've pre-installed a couple of packages. This machine can be easily discarded afterwards. The second machine contains a freshly new installed FreeBSD system, and importantly I'm going to show that this machine has no internet connection. Okay, let's get this done. So what you're seeing here is my virtual machine that I'm going to be using to create my mirror. This contains already pre-installed packages. So the first thing that I'm going to do here is to clone the repository where I've basically put a copy of the script to create a local cache. And I can do this with the following command, so git clone, and I put repository name here, and I have a version of the repository. The first thing I'm going to show you is which package I've decided to install. I've created a small file here called selected. The selected file just contains a list of packages that have previously been installed, and you can just install those packages using the command that I show here. You can either do this or install packages by hand. The next thing I'm going to show you is where the package software creates the repository. This is done in /var/cache/pkg. If we look here, we can see that we have lots of files in the cache. Let me just make this a little bit better. Yep. So we can see the packages that we have here. We have about 6.1 gigabytes in packages. How does PKG track the packages that are currently installed? This is done in an SQLite database, which is available in /var/cache /var/db/pkg, and we have here a file that's called local.sqlite, which is a pretty big file in this case. We can have a look inside this file. So we run it, it's an SQLite file. The first thing we can have a look is at the schema. And here in the schema we can see that there are lots of tables that are created. Tables for licenses, for directories, for PKG, for users. One of the main tables that is contained here is the table for packages. Let's have a short look at this. Select star from packages. We can see that this system has installed about 1800 packages, and let's see the headers. Select all the columns from packages where ID, let's just randomly pick a package number, let's say number 42, why not? And we can see here, these are the headers in the table, and package number 42 in this system is the netl package, a low-level cryptographic library. Okay, let's quit from here, and let's go back to the script directory. To create the mirror, so I'm still developing this small script, so you expect some improvements. For the time being, you just need to create a directory called mirror and just call the script itself. Once you run here, it's going to build a local list, a list of the local packages. As you see, it takes the SQLite file, which was pretty big, so it's scrapping that database and generates a couple of files and now creates an ISO image. So let's just wait a little bit, and now we are done. And 6.2 giga, and here we have our file, which is the mirror.iso with about the correct size, 6.1, 6.2 giga. Yeah, and that's it. So how can we see the contents of this file? This is an ISO format, so we could, in this case, we could just simply burn it in a dual layer DVD. But I would like to have a look at this file. So for that, I can just go to user, so to root. So I'm now going to configure a loopback device. I can do this with mdconfig -a-t vnode. It's going to loop back on the file present in the gatekeeper, and the directory was the cache and mirror.iso, and let's give it the number 0. Okay, we are fine. Now we can mount this file system. It's format the CD9660. It's available through the loopback md0, and let's just put this into the /mnt directory. ls-la mnt, and you can see, let's again look at this with some nice colors. Okay, so here we can see that there is a directory called all, and there are a couple of files that have been created, and there is the PKG bootstrap. We're going to need this because the target system has been just freshly installed, and the PKG has not been bootstrapped yet, and we can use this small file here to bootstrap PKG. Under the all directory, as you can see, here are all the packages that have been copied from the local cache. Okay, so we can unmount this directory. We can remove the loopback device, and we are basically okay. Now we need to copy this into the host system, or you'd burn this into a dual layer DVD, or use it as we're going to see. So export this ISO to any shared folder that you like, and since it's a CD format, we can really easily mount this into another virtual machine. For this, I'm going just to configure the VM HDFS, so I'm going to configure the shared folder, and I'm going to put this under the /mount. We have a shared folder here, and I'm just going to copy the so home, gatekeeper, the cache, the mirror to the MNT shared folder. It takes a little bit. It's a relatively big file, 6 GB, but since everything happens in the my local machine, it should be relatively fast still. Okay, we are done. So now let's switch to our target machine. So here we have a target machine. This is a machine for testing. Let's first have a look here at the network adapter. We can see that it's currently connected. So let's disconnect the network adapter. And we have, we can include here in the DVD, we can just say we want to use the mirror that we just copied. Okay, everything looks fine. We have the hard disk. We just included the mirror as a DVD, as an external disk. We are ready to boot the machine. So let's go for it. Okay, starting up. We can just log into the machine, and let's test connectivity to internet. As expected, the network is down. And now let's mount the DVD. The script that I provided assumes that you are mounting the DVD under the /mirror directory. So let's create it. This can be easily changed. The command is similar to the previous one, but this is a device CD0 because it's mounted as a DVD, and it's just going to be mounted on the mirror. ls/mirror. Here we have our files, and let's see. The first thing you can notice, PKG is not bootstrapped. So how can we do this? For that, we can just use this small file that I created here. We can extract this *xvzf mirror PKG bootstrap, and we're done. Let's see. PKG, not enough parameters. Before we use PKG, we need to do still one small setting. We can go to etc PKG, and under this you can see now that there are two files. One is the FreeBSD.conf and one is the mirror.conf. Let's have a look at the mirror.conf. Vim is not installed for sure. So you can see that the FreeBSD mirror is basically pointing to the directory here, that is the /mirror. This can be easily changed. So let's imagine that you mount a DVD in /mnt. You just change this file, this URL to point to /mnt. So currently I'm not going to save these changes because I want, I've mounted it under /mirror. And what I'm going to do is I'm going to look at the FreeBSD.conf, and it says here that we can disable this by creating this file, but I'm a little bit lazy. I'm just going to write here no. Okay, looks fine. PKG update, and look, there is 1700 packages which are available. So what is my favorite way of bootstrapping systems? Installing the best text editor that is existing. Which one is it, you might ask? Vim, for sure. So PKG install vim, and I also like to use Midnight Commander. Look how fast this goes. This is in real time. MC-U, and you can see that we have just installed Midnight Commander with a machine that currently has no internet connection. Let's do just one small last demonstration. So PKG install xorg and xfc, and see how fast is going to be the process. So here I'm not fast forwarding the video, this is just going at the standard speed, and you can see it's pretty fast. And let's try to get xorg running in this machine. So /vim is now working, so should be fine. bootloader.conf. Under VMware we need to load the UMS driver. Load yes, and we just do a sysrc dbus enable equals yes, and let's just reboot the machine. Shut down. I could do a KLD load and a system start, a service start, but I just prefer a brand new start of the machine. So we just log in as root. You should never be using root by yourself. This is only for the demos I'm showing. I'm a relatively lazy person. Start xfc, and lo and behold, again we have xfc is running happily and no internet connection. Awesome. So that's it. If you have any questions or any comments, please write below the video. Otherwise, thank you for listening and see you next time. Bye bye.